All right, we're gonna do letter B, D, which deal with radicals, your square roots and your cube roots. So we're gonna go ahead and do letter B, which is 3 cube root of 64 x to the 5th, 250 y to the 9th. Okay, split it up. We're gonna have the cube root at the top on just the 64 x to the 5th, and the cube root at the bottom, 250 y to the 9th, right? Because we can split up roots. Again, we're gonna split up the roots. So we're gonna do the top part, okay? We're gonna have 64 under 1, and then the cube root of x to the 5th. We're gonna do that to the bottom. We're gonna separate them all so we can see how we can separate everything. Okay, now, okay, 64 is a perfect cubed actually, because that is a 4 cubed. Okay, now I can take out 3 from this 5, so I can split it up as 3x to the 3 and 3x squared. Okay, because I want to take out a 3. I'm trying to take out a 3. Boy. Making it bigger so you guys can see. Now at the bottom, okay, I'm gonna do the same thing. 250 can be split up into a cube of 5 cubed times a 2. And I'm gonna split up this y to the 9 3 times. Because that's how many perfect cubes are in that 9. Because y3 plus y3 is a y9. Okay. Now I can do the simplifying. Okay, so for the top part, I'm gonna come down here. I have 4, because I took out a 4, an x, because I took out an x, and I'm still left with the cube root of x squared. Now, at the bottom, I can take out some stuff too. At the bottom right here, I'm taking out a 5. And I'm taking out a y and a y and a y, which makes it y cubed. And I still have the 3 square root of 2. So after I did the simplification of all these numbers, now this is what I'm left with. I still have to simplify because I have a radical in the bottom, okay? And I have a cube root of 2. To get rid of a cube root, I need to make this able to come out. The only way the 2 can come out is if I have 2 more 2's. So what I'm gonna multiply by is the cube root of 2 squared. So that when I multiply these out, all the 2's can come out. So I'm gonna go the cube root of 2 squared. Now I'm left with, if I have the top, I'm multiplying this times this. This goes back inside there. So this is 4x cube root of x squared times 2 squared. All over, this is now making 2 cubed. So I can take out the 2. So now I'm left with 2 times a 5, which is a 10y cubed. And if I continue, I get 4x 3, 4x squared, all over 10y cubed. So you're simplifying and you're trying to take out all your cube roots. Okay, now let's look at number D. which is -3 square root of 18 plus a 3 square root of 8 minus the square root of 24. I'm gonna split this up. I'm gonna split all of these up, okay? When I do that, I get -3 square root of 9 times square root of 2. Because 18, 9, and 2, 9 is a perfect square. Plus a 3, 8, there's a perfect square of 4 square root of 2. Minus, again, there's this perfect square of 4 square root of 6. I'm splitting them up into perfect squares that I can take out. This becomes a 3. So I have a -3 times a 3 times the square root of 2 plus a 3 times a 2, because the square root of 4 turns into a 2, times the square root of 2, minus this 4 turns into 2, square root of 6. Now I can simplify again. This is -9 square root of 2 plus 6 square root of 2 minus 2 square root of 6. I can add these two because they share the same radical. They're both square root of 2, square root of 2. So I can treat it like an x, like a polynomial, like a letter basically. So if I have a -9 plus a 6, I actually have a -3 square root of 2 minus a 2 square root of 6. And that's my final answer. I cannot simplify because these two are now two different bases inside the radical.